of virtual labs or V labs came into picture. This concepts of virtualization or V labs basically started in the area of 2000, around the time of 2011, and after that, people actually found it has grown by leaps and bounds, because it is actually a technology which people have never thought that could be brought down. I mean, could brought into practice, because last many people thought that you have to go to the laboratories and practice. Today I will show you and also give you a demonstration that what is actually virtual labs, how it was developed, and how it is actually giving a innovation in technical education process through a few lectures, and also some demonstration, real-time demonstration of how these labs were the practices. Okay, so now the question is, what is a virtual lab? Can virtual labs be replaced by can virtual labs replace the real world labs, and so forth? So the idea is that virtual labs can never be a replacement of the real lab. If you want to have a hands-on experience with the lab, the person has to go to the laboratory, make his or her hands dirty, and work on the infrastructure, with the infrastructure. But now again the question said that the same thing about the NPTEL. So if you want the best quality education, you have to have and go to the bigger institute, work with the senior faculty members, and then actually you can get a thorough knowledge about it. Now the concept basically is that if there is not available, then what best you can have? You can have video lectures or an NPTEL kind of a lecture. Same thing about the labs. If you have very good infrastructure, that is fine. But still, if the institutes which, because in a country of about 130 million people, is very difficult that everybody will get access to good quality lab facility. So in that case, and another very important thing was find that many of the lab infrastructure in the top institutes were only 30 to 40% underutilization. So can it be leveraged by other students sitting in different remote parts of the country be used? So two important concepts came into picture, that can we have labs, virtual labs made in a virtual mode. Virtual mode means they are in simulation mode. You go log in, perform the experiment, and come up. Okay, then the question arises that there is already MATLAB. There are so many simulation tools in Cadence, Synopsys. Okay, then what is the use of a lab? Now the concept is Cadence, Synopsys, or if you say MATLAB, or any other tool for that matter, Pi, Weka. So they are very generic tools. They are not so specific that it is dedicated for one lab session or one lab course. So the idea here was that they should have a full philanthropy of a lab of 7 or 8 experiments, that is as per the syllabus of an institute. So when you go for a lab in the undergraduate course, you have a lab manual. Before going to the lab, you have to do the theory. Then there are one experiment. You do the experiment, the faculty will give you marks, and the lab is over. So same way, the tools of course are always available. Like as I told you, MATLAB is a very well-known tool. Then this LabVIEW is also a very well-known tool. So those tools are available, but these tools are basically, first of all, they are paid, and secondly, they are a generic tool. So you have to convert it into a lab kind of a syllabus so that it can be utilized in a more, what I show is the formal manner in the formal education system. Like for example, books are already available, then why the NPTEL? Same idea. So now again, another importance is that these labs are anywhere, anytime lab. So even if in a top institute where a lot of lab facilities are available, but still why we are lacking in the lab expertise? Because Indians are mainly known for the software development. The idea that was found out was, actually there's a very big committee under Professor Ranjan Bose of IIT Delhi who were given the task to find out this lacuna. Why Indian people are actually having a slightly less expertise in the physical or hands-on experiment. So what came out was a very interesting fact, that all the students before the exams, they can revise the courses in their hostels, they can read through the internet and so forth. So it is something like 24/7 education system. You can revise the teachings you have been done, and basically a student learns mainly when they are actually preparing for the exam. Same thing is very difficult for the lab. Once in the whole semester, you may be doing the lab, and that also in a very top institute, no single person can be given an equipment. So the students basically have to share the equipments, and maybe the 2 or 3 very enthusiastic people will do the experiments, and other people will hang around, and the exams are over. Basically the experiments are over, and in the exam many labs basically you have some kind of a viva and maybe a very superficial kind of an exam, and mostly before the exam in a lab you cannot revise. If you say that I want to go and revise the lab, actually people will say that, you have to come to them the extra lab hours, apart from the faculty members, the lab staff should be available, and so forth. There are a lot of difficulties. Even if, I mean, the labs are open, you may not get people who will be there to help you out in the lab. So the labs are once in a lifetime of a labs kind of a concept. But with the virtual lab, that concept is eliminated. So the labs are free to use. You can directly access to a laptop or smartphone, and basically the idea is an anytime lab. So you can log in anytime. If you want to revise it like in a textbook, go revise the lab, and basically your job is done. So it is actually in that philosophy it has been developed. And as I told you, there are a lot of tools which can help you to develop. I mean, you can as a tool, I mean, like MATLAB, LabVIEW, etc. But they're all paid tools. So therefore, for the student, it becomes difficult to have an access to them. So here, all the products have been purchased and they are put in the lab, I mean, servers, okay, and in this, I mean, cloud servers, and therefore everybody can use. So that is what is the idea, and they are all being basically developed in a self-learning mode. That means self-learning mode means a complete syllabus, the end-to-end course, not like a tool like MATLAB, which you have, use it, and then you are on your own. It's not like that. Okay. So this is what I am saying. So equipments are very expensive and proliferation of quality labs are difficult. So therefore you can do labs in the remote mode. Okay, so basically this was the idea of the virtual labs. So there is an internet and there is a virtual lab server. All the remote users just connect. You just need a desktop, and all the important software, all the tools you require will be in the cloud, which will be procured from the virtual labs government funding project. And this for the student is just a matter of internet. So, I mean, this is a very well-known thing. So, this was the entire team of virtual labs. And also one very interesting concept, why we call it leadership in education. This lab was developed only by the students. This is one of the very important projects in the government NMICT, where only the student community was involved to make the labs. It was not given to any industry like TCS, Wipro, who were helping us making the lab. It was no. It was only developed by the student community and mainly by the interns. Because if I want to develop a lab for, say, Shankaracharya or for CSVTU, it is their students and their teachers will know what is best required in the syllabus. So it is only those people with the help of the 7 IITs had an access, and they have made this labs working. It's a very pride for the student community. So these are all the institutes which participated and made this lab. Okay. Well, I mean, we'll have a full demonstration session. So the theory part, I'm just keeping it a bit left, because when I say about labs, it is more on basically showing how it works. Okay, so I mean, basically the remote access to lab student, it can mainly, but it is when we talk about lab, it is mainly they target at the UG and the PG level, because whenever we go to research scholar or higher levels of lab, one thing we have to understand that such labs basically will be quite sophisticated, and basically it is very, very difficult to be mimicking those labs. So therefore we are in this project, or in this, I mean, idea, so the mainly people were actually mainly they were working on the labs which were basically at the undergraduate level. It was easier to because anyway you have to develop these labs, so it should be very complex, and the most required, or the popularity of the labs, as you will appreciate, is only for the undergraduate. So mainly if you are going for a PhD or a higher education, you generally have good infrastructure access. So therefore it was maintained to cater to the requirements of the society. Important is just learning management system. So it will involve, not only involve labs, it will involve web resources, video lectures, animated demonstration, and self-evaluation. So it's a package in all. It's not like person has to go and search in the web and then actually go for the lab performance. So it is mainly, the idea was to cover the entire spectrum of engineering. So we start from electronics, communication, electrical, mechanical, biosciences, and also interestingly few areas of humanities, physics, chemistry have also been included. Now, there are always a lot of question and debates. Okay, that if I have a lab which is virtual, okay, then what is the requirement of physical labs, which is the best, and so forth. Okay, so the idea here is physical lab, of course, it always minimum, if you take a lab for the undergraduate and also for engineering, leave apart the chemistry, physics, and I mean kind of sciences which require very expensive equipment. Typically, a few lakhs of rupees are minimum required to set up a physical lab. In case of virtual lab, it's almost new. You just require a laptop and a mobile phone and connect to the internet. Availability. So even if a person, even if an institute have very high quality labs, the problem is that if you see, there will be limited time and space. That is one thing very important, that even in a IIT system also, and even in very top class universities of the world, if you think about the undergraduate education, so in that time, in an entire semester, maybe you will be able to do the lab once, and that also I say that is done in a group. So labs being done in a group basically implies one important thing. What I was saying is that because this is done in a group, so the entire end-to-end experimentation time is rarely felt or experienced by a student. And but in case of virtual lab, is designed for 24 into 7. Now, this is a very important thing, limited options for innovation in lab. So many people used to say that if you are going for a experiment of a gravitation, the way Isaac Newton might have done the gravitational experiment, you are still doing the same way, no changes. And even if you try to make some changes, as you know, our lab experts or the lab staff, these people will come and say that no, you cannot make such connections. Such connections may lead to a lot of problems, and the equation may, and the experiment may be damaged. So therefore, we are not allowing you to do such kind of changes or such kind of a system. So this is the manual. You use the manual, go by it, and accordingly you are to go. So therefore, it is something like you go to the lab, and as a, what do I say, as a, I mean, I should not call it as a clerical job kind of a thing, but it's something like a mechanical job. Connect it, take the measurements, and go out. Virtual lab actually is a big innovation in that, as we'll show you also. The very big idea of this virtual lab community is that you can make mistakes. So you will find that it's more of a simulation kind of a thing. So you can connect your equipment. If you make a mistake, the tool will tell you, see, there is a problem over here, so you cannot take this infrastructure. I mean, I should not call the, I mean, infrastructure. It says that there is an error. Okay, so due to this error, what is the problem that you are getting? See, this may equate to a damage of the equipment, and you are getting all these inputs as an interface because you are using a simulation on a real equipment and not a real equipment. Had it been a real equipment, such would have been a real problem, as already anticipated, and nobody would allow you to do that. But then you also do not learn. Unless you make mistakes, you do not learn a subject. So virtual labs actually allow you. So if I tell you, so if you look at this, is basically the factor where you can do lot of innovations in the lab. So that actually makes the virtual lab a real playholder among considered or among the physical labs also. But for the user experience, physical labs are mandatory. If you see that, so this is the best, and basically this is second best. Okay, that of course, I mean, you must, or you should never have the feeling that if you basically go for a virtualization of a lab, so I mean, physical labs will never be required. This can be said that this can be an add-on, and for the extreme cases where there are very few people, I mean, very few less infrastructure in some places, then it can be a replacement. But again, repeating, that is not actually a desirable thing. It's only a add-on to that. So mainly it is for students who do not have good lab facilities. Students with incursiveness will be triggered and motivating to take up higher studies. So basically, I mean, sometimes some of the high school students also want to do some kind of experiments because they are maybe interested in some kind of physics experiment, chemistry experiment, or even look at some kind of mechanical, which may be for the engineering students. But you know, if you think of a real world scenario, they will never have any kind of access to them in that sense, right? But in case of virtual labs, it does not identify whether it's an engineering student or it's an undergraduate student or a plus 212. They can come and even do some lot of high-end experiments and get motivated that which branch of engineering they prefer. Because many times we hear that I have taken computer science or I have taken electronics because my friends have taken. So I really do not know much about the subject. So one very easy way of exploring the subjects is that you do some of the virtual labs from computer science, from mechanical. Although people may not have a very good understanding at this point of time, but still the idea is that still they will get an idea about what the subject is talking of, what it concepts, and the students can get an idea of which engineering area of engineering he or she may be more interested, right? And researchers in different institutes can collaborate and all. So basically, if you tell that what is the virtual labs, how it helps us in learning, so therefore it can be said that it's an on-demand lab, but you can learn at your own pace. You just revise in your experiment. Morning, maybe one day lab you miss because you were ill. So in this case, in our modern education system as well, will mark you absent, and then we'll say that as it's only a lab, so you can pass the course. There's not a problem. So therefore, you are passing an engineering curriculum, and maybe one or two of the fundamental experiments you may have never done in your life. So, but in this case, this can be addressed by virtual labs. Okay, then there is an integrated learning. One thing I would like to say that many, as again I'm repeating, is not a soft simulation software. There are a lot of simulation softwares available in the market that can help you do virtual labs. But now it can never be that it's not a complete module. So when I deal about a virtual lab, it's a course in itself. It will have experiment one, it will have the theory, you will have the semester in which has to be mapped and so forth. So therefore, it's an integrated learning environment. Self-evaluation, animation, of course, like with all the labs, you will find out that the virtual or the MOOCs course or the NPTEL course has been linked. And most importantly, the freedom to make mistakes. That is a thing which can even the real life lab can never give you in practice. Okay, so these are the things. So now actually we have shown you that we are showcasing. Sorry, we are showcasing up to phase 3. So very recently we have also completed phase 3, and so we are actually phase 3. So slowly it has started from the year 2019, 2009, and now we are in the area of 2022. Still we are now getting into phase 4, and number of experiments are being increasing, and also we are making tailor-based experiments. So there, the way the computer architecture may be taught in Assam University may be very difficult in CSDTU. Or I mean, I should not say the material and the basic philosophy, but the syllabus may be slightly different. The way of delivery may be different. So all the faculty members at different universities give their specifications, and accordingly labs are tailor-made. So that actually makes the beauty of virtual labs. So if you look at the impact of the project, it's very interesting. You can see. So we have around 650 nodal centers, over 30 lakh usage, and about 3,500 workshops. So basically, many people have heard about what is a virtual lab. Very few people really use them, and very few, I mean, use them in the sense in the examination or the formal curriculum. And basically, many people do not have an idea how it is. So therefore, people have been moving around different centers, trading out the people, and so you can see the numbers we are at. And most appreciation about this technique is that it is developed by the students. We have not given a single penny to the industry to make it develop. Everything is in-house developed in the academia environment. So therefore we say that virtual labs, the concept of virtual labs is a real innovation in the technical education sector. So these are these examples of a lot of workshops that we have been doing. So it is something like people call the win-win situation, because equal opportunity for every student. So I mean, people who are not very lucky to have access to good quality labs and infrastructures, so it's an equal opportunity. User convenience, you can do the lab at any point of time. Secondly, basically you can say that you can make mistakes, you can learn more, you can do on your own. There's no team kind of a thing. So in a lab, most of the time, if you say that it's a 3 people group, so at least one person is actually slightly lagging than the others. So he throughout his life he may be crippled in that lab because he was with a very good team, or a person, if the person is a very bad team, both are equivalent. A very good team, he will also not learn, and the very bad team, everybody may be sleeping. So in this case, the single person doing the lab. Next important part is there's no financial obligation. So once you pay fees to your university, and then again still if you have to come and basically say that I have to do, still I have to pay for some other extra courses, those things are also not. It's just internet and a computer. And nowadays you know that the internet has become really cheap in India, around the logic gap and all those things. So therefore in a nutshell, it's a win-win situation for every student of the I mean, it's not only been used by India, lot of people has been doing it. So now one very important thing, as we'll slowly look at the demonstration. So we'll see that this virtual lab, something is like a video game. So it's just like, I mean, if we want to practice and see what happens, but the idea is that flipping a book will not make us learn. You have to read explicitly and understand what is happening. That means virtual labs is basically not a click kind of a game. It's a real world lab. Really everything has to be read in, and then only this exact philosophy will come up, and the learning philosophy will come up. So with this, we actually come to the end of the theories of the story of virtual labs, and it is always better that we have a demonstration. I mean, better what I'll do is, so I'll just take a few questions if required, and meantime I'll just switch on my I'll switch to the demonstration mode. So if anybody has anything to ask, any questions. I
Sir,
hope
good
think.
morning.
Yeah, please.
Yeah, thank you for the session, sir. Sir, I want to know,
Huh.
according to you, which lab is better? Like, is it physical lab is better for the students or virtual lab is better?
See, actually, always physical labs has to be there. It's mandatory, right? Only
Yes,
thing
sir.
is, only thing is that virtual labs is only a add-on. I should say an add-on. Add-on in the sense basically that if some institutes are not having very good labs, they can be used, and in a very good community where labs are also available, students are doing it offline, right? So that is very much off. They are doing it offline and they are coming to the labs and doing it, but they
Yes,
never get a chance to revise the lab. It is once in the whole semester they do it, and in the
yes,
exam also maybe they will do one experiment, so you can easily pass through by not actually maybe say with 30% efficiency in the lab. But to pass in the theory course, you need at least a good amount of, you should know about the subject, at least I say 80% knowledge of the subject has to be there. But in the lab, generally done, experiments are done in a group. Exams are also that, it's not that you have to do all the experiments in the exam. So therefore, in our country, in the Indian context, labs are done in a much superficial level compared to the theory. So, but if you say you can bring the virtual labs into a play, which can be a formal part of the education, along with the real labs. So real labs they will be doing, and on top of that, you say that the lab also has to be completed virtually, because then you have to do the lab alone. Or it can be said that you first complete the lab virtually, then you come to the institute. I mean, then you come basically to the so-called what I would like to say, so-called the real lab. Then it has been found that people will be learning the labs in a much better way. They have a full idea what he or she is going to expect, and they go down there and then they perform it.
yes, sir. Because according to
But,
my view, I feel that the students will learn the skills when they are thoroughly conduct
yeah,
the
in the
laboratory
lab,
through the
right?
physical
So
manner.
right. So that is actually, it is only an add-on to the general labs.
Yeah, yes, sir.
But yeah, but actually in the Indian context, a person goes to a lab and do an experiment only once in a lifetime. Here the labs
Yeah.
are there; they can always revise and practice. So therefore, it is never a replacement; it's only an add-on.
Sir,
Add on.
one,
Okay, sir. Thank you, sir.
sir, can I ask a question?
Yeah, please, please.
Sir, actually, virtual labs are either created like at IIT levels or whatever it is, and many of the subjects they don't have virtual labs, sir.
Right. No, that is what I'm saying. The labs were created by by the IIT community based on the inputs from different universities. Okay.
Exactly, sir.
Like for example, the lab.
What is your suggestion? We should contribute for the virtual lab, or we should use? I mean,
No, there are two way. Actually, how the lab, I'll tell you, this phase 4 virtual lab is also come to IIT Bhilai as a nodal center,
okay.
as a coordinating center. So
Okay.
initially what happened, all the seven IITs along with few universities had the virtual labs as a coordinator. So they collected the lab requirements or the syllabus mapping requirement from different universities. Okay, after they have tried to find out what is happening and what is the, I mean, so-called, what is the, I should say, what are the lacks of the, I mean, means what is missing and what they have to do. So the syllabus mapping was collected from different universities. Once the syllabus was collected from different universities, then the IIT team built those labs for those universities. So virtual labs are not basically for the IIT system.
Exactly, sir. Very small type of
Right. So,
exam.
right. So, whoever actually said that they want to get a lab, them like us too, many of the Mumbai Western universities, like Mumbai University, then Delhi University. So, many of the places from those areas, these labs have been developed. So, it is actually coverage of the local universities who have done this development lab. That is what is the idea. So, if for example, a lab has to be developed for the CSVTU, then in phase 4, they have they are reached to more larger community. Okay, and by the more larger community, now basically they will be going to the university, collaborating, finding out the gaps. Okay, and that's why after finding out the gaps, basically, what do I like to say is that the labs will be developed individually for this. So this using of the lab is one that is very important, because development lab is only once, but it has to be used by the student for a large amount of time, right? So contribution in development and also usage. So both are welcome from all the parties. And
Okay,
that's
ma'am.
the idea. So
Okay, sir. Thank you, sir.
because soft students, lab developers will be sitting in one central place. The participation is in the way you actually tell that how and what has to be developed. Yeah,
Sir, I have one more question.
please.
Uh, Sir, can we use these virtual labs for teaching any language?
See, actually, there is a lab. I will show you a lab. There's a lab on human, I mean, social sciences. There are a lot of labs. Okay, so one lab is on English, technical English. So many people use it to learn before their campus interviews, basic mistakes, basic questions. Okay, so that is about language. And of course, if you're talking about C and C++, I'll give a thorough demonstration now that how you can see improve your C teaching by those labs.
It was about English, sir.
All right, both
Technical
are there.
English.
Both are there. I'll show you.
Yeah.
Both the things I'll show
Okay,
you.
okay. Sure. Thank you, sir.
So any more questions? Or we'll go to this lab demonstration kind of a thing. Okay, so I think, yeah, there's no more questions. So let us go to the virtual labs platform. So I think my screen is visible. Yeah. So therefore, I'll just show you what is basically the virtual labs. So it's a, I mean, this is the, so there are a lot of mirror sites. Now many people have done, because these labs are anyway downloadable. People can even download these labs and install in their premises. So that is also possible. And the main site is vlab.co.in. I think you can have a look at it. So that is, sorry, this is www.vlab.co.in. So this is the main site where all the virtual labs has been hosted. So as you can see, how to become a nodal center, outreach portal. Okay, so in this case, just loading. So in this case, you can, if you look at this place, they will, I mean, they just show this how many nodal centers, all these live informations actually come up. So how many lab participation. So anyway, that is not very important for us. You can see. So you can see that a lot of nodal centers have started around Chhattisgarh. So mainly with the phase 4 coming of virtual lab, so they will be having a major focus in this area. So if you can look at, so there is a lot of blank areas near the central region. But if you look at the southern region of country, so if you can look at the southern region of the country, there's a huge popularity of virtual labs. So this now this mandate has been given also to target the central part of the country. So that how the IIT Bhilai has also become a nodal center in the phase 4. Okay, so now you can find that there are a lot of subjects like electronics, computer science, electrical, mechanical, bio, civil, every areas of engineering you will be able to find different virtual labs. Okay, so let me try to just show you first few of the lab demonstration. Okay. Okay, so okay, so one by one I'll take. So first lab, I just am taking all the labs actually is a huge level. I mean, so that for example, I have taken one lab from the digital VLSI design lab. So this is mainly MOSFET, CMOS inverter, ring oscillator, logic gates, multiplexer, latches, and register. So if you look at this, so if you're teaching virtual labs from the IIT IIT Bhilai syllabus, or maybe some universities in CSVT, will be slightly different. So in digital VLSI lab, we have adders, multipliers, subtractors, and so forth. But this digital VLSI design lab at some of the Assam universities, Manipur University, they start with MOSFET, inverter, oscillator, then logic gates, multiplexer, and latches. So they have more emphasis on the. So what do I say is that these physical gates, and a little bit on the higher layer like multiplexer, latches, registers, and so forth. But many of the other universities starts with basically logic gates and go up to final state machine level design and so forth. Right. So therefore, the same lab have different flavors, and based on the demand of the universities, both the labs have been developed. So that is what we are going to, I was trying to tell you. So that it depends on the demand of the university. The same lab maybe with a slight change in the syllabus, and both of them are there. So that is the idea of virtual lab, is that it is not only to be used by the student, but it should also be used in the formal mode of education and as an add-on to the physical lab. That is what was the requirement. So let me just show you. So as I told you, it's not just basically a simulation tool like a MATLAB or something. It is there, you just go and simulate. So it actually has a normal way we do to a student. So it will have, it's for an inverter, CMOS inverter. So inverter basically means if you give an input 1, the output is 0 and so forth. It's the analog one, you can get an inversion of the signal. So it will always give you the entire theory. Okay, so I mean, I'm not targeting any kind of particular branch. Just I'm trying to give different examples from different branches, so that I can actually tell you, I can actually explain you that what is the basic spectrum of virtual lab. Going into depth for each of the areas is a matter of subject expertise. Okay, then before you go to any lab, generally the idea is that there is a questionnaire. So as some professor was asking that, I mean, what is the difference between me? Can anybody forego the virtual labs, forego the physical labs and go only to the virtual mode? So again, the answer is it is not possible, not desirable as well. Why this so? Because nobody can replace a real physical lab. But if I say that, I just say that if you have to come to the physical lab, first you have to complete the virtual lab and then you come to the physical lab. So in that case, it will be very good because you know exactly what is going to happen, and maybe already what you have done in the simulation, same thing you will have to be able to replicate this. But you will have a thorough knowledge before coming to the lab, which is generally lacking. Secondly, as I told you, the people may get a very less amount of flavor, or because you have to do the labs in group, so that may also be a problem. But if I have the assumption that everybody has already done the lab once, so it's a very good help from them. So therefore, it's the first set of questionnaire you have to pass, that is the theory part, so that it ensures that before going into the lab, basically everything is, I mean, you have to have the knowledge of the theory, because most of the times we know that for us the lab was nothing that go to the lab. Okay, maybe you try to be a part of a very bright group. So if you are part of a very bright group of students, then basically your life is peaceful, because these many other students will go, you learn on their hand itself, right? So this has been a practical experience for many of us. And basically your learning actually comes realized. But here actually the idea is that you have to have a full idea about the theory before you can go to the physical level. So that actually boosts the confidence and the utility of learning. Then it also, just like a normal lab, if you go to there, you'll have that step-by-step procedure will be given to you. Then only you can go to the simulation. I'll show you the simulation. Then there will be assignments, references, and even video lectures. Okay, so video lectures will also tell you what to do. So as I told you, it's a package in itself. Okay, so now if I say that if you open an inverter, so this is a CMOS inverter. Okay, as I understand, the faculty members for different domains are there, so I'm not going into the idea, basically going to theoretical depth. But from the electronics people, they may know this is a CMOS inverter. So different type, sorry, it's a MOS output. So I am not talking about inverter, right? This is MOS output. So what basically you do, you give different voltages output, and you can study the VDS IDS characteristics. And these are some of the parameters of this transistor. So these parameters can be changed by different value by editing here. And after that, if you say simulate, so you are going to get the value out of it. So exactly what you do is that basically now you take a transistor, you take different type of transistors, apply some different voltage levels. So you can see the different voltage levels, and you can get what is the current level at the output. So you generally kind of voltmeter and a ammeter to do that, and or you put a CRO oscilloscope and you get the values output here. So in that case, I mean here this voltage changes basically can be done by putting, you can see that some of the voltage values here. So VDS is 1.8 volt over here and so forth. So you can change all these values, because it is not a physical lab, so you cannot have any equipment to tune on the value. So you can change the values here, and then if you run a simulate, this will be CRO output. So here it is changes is by manual values, but still you get a thorough idea of what is happening. I'll take you to different labs, and different labs have different perspective. So this is one idea that, and then whenever you go to a lab, you get different transistors with different values, change the value of voltage, change the value of current, and change the value of voltage and VDS, and you can get this value in the oscilloscope. So once you have a knowledge here, you can see that whether the same thing will happen there or not. And of course, there you will find not exact match, because it's an ideal situation. Whenever you go to a lab, the real devices will be there, so there will be noise, disturbance, and so forth. Exactly. So those differences you will match. So in that case, then you will find out that the students will really understand and will be happy that there is a difference between a real lab and basically when it goes on for simulation. But you will always know, you will understand the physical lab much better if you go for a virtual lab. Okay. So now let me take you through another lab. So again, I'm repeating that I'm not going in the full details of implementation and showing you the implementation, because the idea here is that it's not to teach the virtual lab course, because this is basically a course on innovation in education. So I'm just giving an overview how things have been changing, what are the innovations in technology education, and how virtual lab is playing a role in that. Okay, so another very important is digital electronics. or the digital VLSI. So in that, as I told you that the last experiment you saw, the experiments were mostly like inverters, CMOS, gates, room oscillators. So they are basically at the device level. Now the same the other universities in the Northeast, they have actually called the digital electronics. Mostly the course is same. For first year or second year students, they teach it. But here if you see, the number of experiments are slightly different. Okay, so now again, if I say that I want to make a half adder, so first we will have a theory. The entire theory will be given to you. Again, I told you a pre-test. Every virtual lab is coming to a pre-test. So unless you do the pre-test, I mean, this is a demo version, so I have kept that feature off. So if you have to have a pre-test, you have to pass this pre-test, then only you can go to the next level. It's a procedure, how to do it, and entire data set. And that is why I'm saying everything is available in one place. You need not Google out and start doing everything. Not required. Then it's a simulation. So you can see this is a very interesting set of experiments. So these are switch, you can put different ICs, make connections and test it. So what happens is that first the student goes to the lab and asks for the components. You have to go to the lab person, and lab person will give you the 2 or 3 ICs. Just like you have to drag and drop. It's something like you put these ICs and put in the board and start doing the experiment. So there are some switches. So you just connect this to the different switches. And now say that if I say start, okay, sorry, mistake. I say start, it will say please make ground and VDD connections, right? So in that case, what happened? This is one very important feature I wanted to show you. Now, why is it so? The idea here is because if I make a certain connection in the physical sense, and if I say start doing the experiment by putting the switch on and off, immediately there's the ICs is burn out because they're not connected to the power and VDD, and you are giving inputs. Right? In the virtual labs, you can do that because they are more in a simulation mode and it's just getting a warning. So the student will now, and if you really do this in the main lab, basically you will be thrown out of the lab because you are actually damaging the equipment. So this is a big problem. And that will be a major, so I can say issue, and the students will never be allowed to do that. So therefore, we never, I mean, unless somebody has done this and has been thrown out of the lab, basically he or she will never hardly remember anything is required unless he does this in his job again. So otherwise, people will just do, make these connections has to be done. I take a piece of paper, read it, make the connections, when a job is done, and I go out of the lab and never actually repeat that again in my lifetime. Right. So now, but here you see, you can make you can understand that these mistakes are there. These mistakes has been flagged, so you can understand that there was a problem by, and therefore by making mistakes you learn. Otherwise, if you are always doing just following the textbook and writing you just look at the lab manual, just connect it and making a job done, then actually does not solve the purpose. Learning is never complete. So I can just see, and if I want to delete a connection, so it's so simple. So now again, as I told you, these have been all developed by the students. People have never taken help of any kind of industry interface to develop these labs. These are the outputs and so forth. Okay, so I'm not, again, as I told you, I'm not going into the details of the experiment. Rather, I wanted to show you. See, the VDD converters are still not correct and all. So I made a wrong connection in the VDD and the ground. This was generally the last one. Okay, so now you can see that if I start the experiment, I can start and so forth. But again, as I told you, I do not want to, I mean, highlight and few other, anyway, the whole connections has to be completed, then all these things to start working. So that is not a very domain kind of implementation, so I'm not going about. But actually what I tried to show you that exactly this is what is mimicked by a virtual lab. So this actually gives the concept that how virtual labs work, how it is developed, and what is expected out of it. So there is a mimicking of a system. The systems are mimicked in the manner. In the manner so that the students basically have a real life feeling what he is going to do. Going into the lab, he will do the same thing, but of course he is never allowed to make the mistakes. Okay. Now, somebody told me that can we do any kind of a programming course? So actually, I'll just try to say that what is the programming and how programming has been built very efficiently in the virtual lab. So there is around some 200 different virtual labs. Each of the labs are having around 7 to 8 experiments. So it is the idea that people have to go around and start and explore them. Okay, so this is about the programming. So you can see the list of experiments. So this in the programming, the list of experiments is changeable. So people can always add and change the instructions because programs can never be so-called, I mean, fixed. So therefore, this is only a platform and it can be used to teach and learn, and this can be flexible. So there is one experiment. So I'm not going to the experiment because all of us know that, sorry, I'll just take a different lab. Just a minute. Yes. Simulation, yeah. So this is a very interesting thing. So now this is rather than a lab, it is more like an evaluation platform, because as I told you, virtual labs also means that it's a remote kind of education. So one of the most problem we felt during the pandemic is not about taking the online classes, because by that time early 20s was a problem, but slowly the time with coming of WebEx, of the even this virtual mode of teaching we are doing right now, basically had come up in the 20s, early 20s, when the first pandemic layer came. But one of the major problems we faced at that time was the online evaluation. How to prevent students from cheating, copying, and making a fair examination policy. So this is one platform. I should not say about this helps in online examination, but it's a very important thing which can be done in offline evaluation of the programming languages. So generally a programming language like C or nowadays coming in Python, they're always taught at the first year level. And then a huge number of students are there. Everybody almost comes for that experiment or experimentation. Now there is a problem that happen is a huge number of students, and therefore you are always use students to evaluate this or evaluate the labs. So now one interesting things that happen when you are actually evaluating the students in the lab is that there are different type of people. So some people are actually evaluating the lab very nicely. Some I mean faculty members, because a huge number of students in the lab, first year lab, so it's a large number of people involved. So different people teach in different way, especially the evaluation. If some students or some of the teaching assistants are very rigorous, say they will ask lot of input cases to see the code. Okay, and some people basically may say that it's not a very I mean they are not very easy going. So if you are evaluated by a faculty member who was easy going, so you get more marks, and also lack of fairness. So and also one important thing is that in a programming lab, see, if I am able to say that I know the algorithm, I know what to do, but I am not able to write the code. So in that case, even if my knowledge is there, I am not able to write the code because I lack in the programming knowledge, but I know what to do. So in that case, still the student gets a 0. And also in the case which I told you, because they're large classes and you cannot individually go to each and every people and see what he or she is doing. Right, so therefore lot of problems are there. So this module is a self-evaluation kind of a module. So here there is a program which is asking you to do something. Okay, so if you know, you can just type it out here. And also another very interesting things people say that while sir or madam I was doing this lab in my hostel or my home, it was working very nice. When I have come to the institute or in the lab, it is somehow not working. That also cannot be done, because here everybody will be coming. Even if you sit at your home, compile your code here, come to the lab, you are connected to the same cloud and the codes are getting compiled. So if you can know about the entire program, you write down the code over here and you then compile. You can upload your folder as well. You can compile it, run it, and of course there will be automatic testing will be done. Because example I gave you, if some of the faculty is very rigorous, he learns more about, he wants to do more about the course and so forth, and he tests, he may give 10 input cases to the program to see. And if somebody is easy going, maybe he will give 1 or 2 inputs and done. But here the inputs are given randomly, and it takes an exhaustive method of it has a full rigorous manner of testing the courses, testing your program. So it is same level of testing for all the students. So the first thing is there is something called hint level. So if the hint level is 0, you find nothing, you have to write the entire code, compile and run, and if it is running, you are getting the full mark. Now actually say that I want to know what I have to do. Again, I am telling, I am not going into the discipline of this. So it will exactly tell you that some basic, you declare some name, numbers, do something, some very superficial level of information is given to you, because the idea may be that you may not know what to do, but you may know the coding. Because if somebody asks me to find out the average of 10 numbers, a mathematical problem, I may know the C programming or the Python programming, but I do not know the mathematics behind it. So at the level 1, it will tell you exactly the mathematics behind it, so that if you want to do the coding, you can do it easily. But you're not going penalized because of the not knowing of the mathematics behind it, because a programming course. So basically I expect only programming to be known. It may be the case that I might have forgot the mathematics, but still I am not able to, if I do not know the basic mathematical logic, I cannot write the code. So in spite of with no mistake of the knowledge regarding programming, the student is getting penalized. Similarly, but if you take this help, some marks will be deducted. Similarly, up to level 4, and the level 4 is actually giving you the entire code. has to be written. And the entire help. So in this case, you will not get any marks. But then why this help? Because the student is not able to do anything. He's just sitting, not able to write. He's looking here and there, getting frustrated. But in this case, what happens? The student can at least have a final look, try to run the code and understand something. Right? Still, marks may not be less, but he'll not be sitting ideal. Now what he has to do is to compile the code and then you have to run the code. Interestingly, you can see that same in different type of random inputs, like 7 or 8 inputs have been given and his code has passed. Right, so it is, and for other students who will do also, the similar inputs will be given and tested. So the idea is that it's not like some student will be evaluated early, evaluated easily, some will be doing it evaluated less, and so forth. So it will be a win-win situation for all, and it's a fully manual, automatic driven. So nobody can complain about the biasness of evaluation. For example, student makes some mistake. Okay, then you compile and then you run logical mistake, so you can see that there's an error, and therefore it has to change your algorithm. Okay, and if I make some broad mistake in the program, something like this, you can see the error will be there and your code will not be compiled at all and you will be exited. And then you can say that I want to learn something more. I get a hint from level 4 and I copy it. And in this case, of course, the auto evaluation module is running. So the marks actually will be automatically taken care of. So this was one very important lab which was developed for self-evaluation methodology. Of course, it is not, I mean, now a new lab efforts are being given so that how can you make these labs run so that you do not have any kind of, I mean, that auto-evaluation, I mean, cheating, etc. is not done and so forth. So those things are also taken care of. Okay. Some other important interesting labs I'm going to show you. They're not going into the theory, just I'll try to show you the animation. So what happened is that there are two different matrices and the matrices are going to be multiplied. For that, the person has written a code, okay, and he wants to understand that what line by line is happening. So you can see that some of the parts of the lines are becoming red and exactly which part of the array or the data structure is getting manipulated is actually shown by this step-by-step representation. So if you can make some kind of error over here, so if it's a fatal error, of course nothing can be done, but if there is some logical errors, it will just show you that what exactly is happening, which matrix is wrong calculation and so forth. So it's a very good learning step as well as a demonstration step. So if you tell about what is the virtual lab, so mainly it is about, say I've showed you for the electrical machines lab, some electronics lab, where equipments are involved. So where equipments are involved, the real lab in the virtual lab in the real sense. But for the computer science also, they have a lot of impact because they mainly take care of your teaching ability. So I mean, how to improvise your teaching. At the same time, not only about improvising your teaching, it will also help you to demonstrate your teaching in a more live manner. Just as I was showing here, that you can show that there are different lines are there, and which line, like for example, this multiplication is being going, that which answer is being displayed. So that is also the teaching in a very real life, so what do I say, the real type of demonstration. Then just taking you to different labs so that basically we can get an understanding that what is the different flows. So you can see that Python is a very new lab that has been coming up. Some of the labs already has been developed. It's a sorting algorithm. Okay, so and most of the important thing is that people from the computer science will understand that. So sorting in the sense that you have some numbers are given, you have to arrange in the ascending order. So there will be overview. Okay, as I told you, there is always theory behind that. Everywhere is a pre-test. So one of the most important advantage of virtual lab is that you have to first pass a pre-test. So pre-test actually there's a lot of help therein. Right? So just as a question, then there is a aim, not the experiment. So you have aim, concept. So again, a theory manner, demonstration, practice, everything is there, right? So if I go over here, that is a mostly a simulation part. Okay, sorry, there was slight network disruption here. So what actually is an algorithm? So there are some numbers in a list. So I can even, if you see, I can reset the numbers. So you can say I can use different numbers and see the working of this. So when a student is being taught in the class, so therefore the teacher will generally take one example and run through. But when the student wants to learn about that, he can take different input, different numbers, different number combinations and see how it exactly works. Then he can himself write down the steps, and it is, I mean, I'll go for a reset. So in this case, the student has to do that. So what is a bubble shot? So basically you have to find out if the numbers are in ascending order. So what you have to do, you have to find out the two numbers, and if the two numbers basically this is not in ascending order, then basically you have to swap it. If it's there, it's fine. So here you can see that it's there, so I have to swap the numbers. Okay, then again I go over here, so again I have to swap the numbers. So here again swap, again we have to swap, again you have to swap, you have to swap. So there, and if you do the this number, so if I say that next swap, so you have to do it actually some square number of times. So these are mathematical complexity behind this, and then you will just find out that it is done. And if you actually make say next, and if you say swap, then next. So you see, there is a, it will tell you exactly how it, what will be the answer. So what I mean to say here is that the idea is that these virtual labs in the area of computer science giving what teaching aid. Teaching aid means basically the students can learn on their own. If you go to the class, you can use it to explain, and you do not have to make so many animations in your slides. The animations are already there, and even and basically different type of works also you do not have to do so many, because if the students may want to learn with different concepts, different input cases. Okay, so how many input cases we know and will do? So you can see there are a lot of random input cases as well as given over here. So it has become a very good help for the students as well as for the teachers. And most important is the entire set, reading material, YouTube video, a large number of teaching experience can be achieved over here. So that is what is the concept of virtual labs for many, that is class of it. Okay, so there was some question about general humanities and all. Okay, so there is one virtual lab which was developed generally for this so-called this human, there is a language, English language, mainly technical writing. So virtual English and communication. So this was mainly built because of many of these campus interviews companies, whenever they are coming for nowadays, are actually taking place in the interviews. Apart from technical knowledge, they also have a very fair writing knowledge. So once a person goes out of the academia environment in the engineering, as we are all discussing about technology environment, you will be very surprised that you will know that basically apart from your technical knowledge, you will require a lots of knowledge not only in the technical sector but also in the English language sector. So therefore the technical communication was there. So I'll just show you what type of experiments people had done. So again, everything there will be, this is about business communication. So there will be, I mean, all the theory will be there, self-evaluation, all cases will be there, references will be there. So if I take your self-evaluation, like a matching synonyms. Okay, so I drag the items on the right to the left. So I do not know basically what I mean in inflation. So what does it mean? Maybe escalation, right? Liquidation, maybe settlement. Okay, so this is one type of experiment. So these are some of the technical, high level technical kind of was used in the finance domain and so other forth. And then basically you have, this is an experiment. Now you are saying your score is 25, try again, incorrect matches has been darkened. So therefore these two are correct, but this is wrong. So it gives you actually a very technical it's a way of learning the subject in a, see, for example, for humanity level courses, computer science related courses, they are mainly basically what do you require? You just require a textbook to do that. But only thing is that, I mean, it's just like a book is always there, but unless you open the book and then you start reading and utilizing book, the book has no meaning for you basically. The same thing. So they have been tried to put out in a very nice way so that reading and interpretation can be done in a more interesting way. Okay, so let me show you some more experiments. Okay, learn. Which one is done? Which first one is done for a big, bigger, biggest? Okay, so maybe next I go to do high. Then high maybe higher or something. High, higher, highest. Maybe let me show the questions. Big, bigger, biggest. High, higher, highest. Wild, wilder, wildest. I mean, see, basically the idea is that if I can say that, also the show answer is also given to you. High, higher, highest. Okay, so again, they are auto marking, so you can see your score is going in that manner. And of course, these courses can be, the numbers can be, the words can be reshuffled, changed and put in there. Similarly, for the vocabulary, jumbling of the words. Okay, so the entire philosophy of humanities of English language is one very important course that is developed over there. So just I'm taking you through a what do I say this journey of virtual labs without going into the specific depth of any of the languages. One important, very interesting lab was this is anthropology. So this is something like the humanities. So in that case, I mean, people the excavation, basically this human interfaces. So all those actually come under the area of anthropology. So I'll just show you some of the. I mean, again, just saying that I'm not an expert in this, but it actually mainly takes care of Mendel's law and some of the. I'll take an example of anthropology. Mainly, we understand. So this is one favorite experiment we used to do. This is a very famous hand club which was found long back in some kind of Mesopotamian civilization. Okay, and then basically it was found in different pieces and people have joined to make it. Of course, that different high level fine pieces is very difficult to put over here. So what generally we have is that here it is some kind of a not very impressive way of showing it. So what happened basically was that this type of old traditional anthropological historical objects are found at different places and they may be scattered off different parts, maybe here just like the skeleton of a dinosaur. So you will find different parts in different places. You have to bring them, put them together so that you are going to get a very straightforward argument. So argument, I should not say argument, straightforward. You can join that and you can get an entire system, and that study is basically one important part in anthropology. This is a handout. So the real sense this should have been broken down into multiple pieces, but it's not the case right now. So the idea is that if you want to find out what, because initially actually I showed you. So this is the case, but generally in the case you are not going to get a smooth out of it. You will get some broken pieces and then you understand and make it. And the real case that why we have made this lab in this manner, because there were people who told us that these are the devices which are found at very different places and we do not have basically so much access to all these museums across the world, so that if we can have some kind of idea which we can give to the art students that how basically it is done. We can go for a final level broken up. Okay, but for the demonstration we are showing a very simple one, but I have an advanced one also, but connecting it even it will take a long time for me. It's just like a simple jigsaw puzzle, but basically it is to precast the history. And also one more thing, that some of the parts may not be available as well. Non-available in the sense that you will even know, they may be lost. So it will be only partially available, and from the partially available objects you have to actually do that. So if you see, can see if I have any joint it back. So therefore you will find out that it's a prehistoric act. So they have finer things, they put it together and they will get out the architecture out of it. Then, like as I told you, I'm not able to do that because it's a complex. So you can see the different identifications of a human skeleton reassembling. Like as I told you, this is true for a human, but for a it's a femoral bone or so actually that is how once you learn by doing it, it will actually be a very what do I say is a once you learn in this manner, so you can, when I'm not able to right. So therefore maybe I think this will be for this part and so forth. So this is the idea of basic idea of anthropology, that you have different parts of a skeleton or different bones of the Homo sapiens or Lapsopesians, the old type of, I mean, Homo sapiens is the latest. I mean, in the development of the life cycle of the evolution of a human being. And the traditional was, they were the Australopithecus, and there are several others. Different forms of lives of human Homo sapiens were there. So this one type of experiment which actually caters to this. So this actually shows that the virtual lab is actually spanning from hardcore electrical engineering, computer science, biology, mechanical, humanities, and so forth. So, and as you see, the number of labs are slowly being increasing, and people are trying to put more and more labs so that, I mean, it can be accessed by a larger community of the people. So I mean, this way we can go and on and on. So but I mean, no point in actually extending more on this. So the idea is that I tried to show everybody that what is the virtual lab, what it brings to the on the table when you say about and say about actually improving the technical education in a different direction. So the virtual lab is the one way to only address this system. So I mean, as this is not particularly tuned to one discipline of engineering or sciences, so I rather basically just try to give you a flavor and the technical, I mean, know-how or technical leadership, if you can get, if you can go for the virtual labs also in a virtual mode of education. So now I think I'll be open up to some questions before we close down. Yeah. So now I would request, if there is a question answer or discussion session, we can spend some time on that. Okay, so that's from my side. Now we are open to discussions. If somebody has a question, I will request to unmute and ask, because somebody has asked, can this be used for architecture? So I mean, the question is not very clear to me. I'll request the people who have some questions, they can unmute and ask, please. Or yeah.
Hello, sir.
Huh.
Can these labs be used or can be helpful for the architectural students?
Yes, see, actually the idea is that it is for any discipline, you have to first find out that what are the type of experiments you want to do, what can be virtualized, and then the whole team of virtualizers who develop these labs are some students who are sitting across the different nodal centers. They develop the lab based on the way you want to design it for the students. And then once it happens for one university, all other students, different universities can use them, and there is slight tuning that is required for the different applications, as I told you, different universities, and that's how it goes. So all these labs have been built on demand.
Okay, sir. Thank you.
Yeah, so if you have any more questions, we'll take it. Otherwise, thanks from my side. Okay, so I think there is no more questions. Okay, so thank you very much for this interactive session.
Thank you, sir, for a wonderful session.
Yeah. Thank you.
Um, hello, hello.
Yes, madam, we are there.
Again, power failure. I have disconnected from the.
No problem, madam. I think the resource person has completed his session,
Okay, okay.
and the next session will be at around 2 p.m., right, madam?
Yeah.
Okay.
So, hello, Santosh sir, Professor Santosh sir.
Ma'am, he has left the meeting.
Yes, madam.
Okay.
Looks like he has left
Yes,
the
ma'am.
meeting, madam.
पता नहीं आज क्या हो रहा है.
No, he left the meeting. Yes, we saw that coming.
Okay. Thank you so much. Thank you all. Thank you all for being patient. So, here we end up the session, and again there is a lunch break, and our next session will start by 2 p.m. So please be connected with this link only. आज आप लोग तो connected है, मैं ही disconnect हो रही हूँ बार बार.
Okay, madam.
Thank you.
No problem.
Thank you.
Thank you, madam.
Thank you, ma'am.
लर्नर जेवण 17 2 लाख स्टूडेंट होते उसमें 17,000 स्टूडेंट ऐसे जिन्होंने